Hey guys, welcome back to the Gust YouTube channel. This is Kenzie.
And Delaney.
And then Avery's behind the camera.
We're the Gust where every week we travel to a new college campus and look at everything tornadoes. So this week, let's look at UConn.
Before we get into looking around campus, let's do a deep dive into some information. As of the late 20th century, tornadoes in the northeast of America have become much more frequent than in the past. Many believe this is due to the hotspots for tornadoes that are originally in the high plains in the southeast have begun to shift east. Connecticut usually in the past has not had frequent high wind events. On average, Connecticut has just over 2 tornadoes per year.
And that number is expected to increase due to a higher frequency of thunderstorms. And this can be attributed to climate change. A combination of different climate change factors is responsible for the conditions. For example, warmer Gulf of Mexico waters creating more moisture and atmospheric instability, drier conditions in the plain regions, a southward dip in the jet streams, and the boundary between dry and more moist air is shifting eastward, shifting the ingredients for tornadoes further east as well.
Now we all know that tornadoes mostly occur in the Midwest and the Southeast due to what is described as the perfect conditions for one to occur. These hotspots are in the best places for one to occur due to the warm and cold air meeting in the right place.
With an increase in the chance for this weather in the Northeast, residents will be much more susceptible due to inexperience with these events and poor infrastructure. It is important that residents are advised on how to handle these conditions and improvements be made to the infrastructure to sustain them.
Let's go talk to Avery on more information on how a tornado forms.
Okay, let's talk a little bit more about how a tornado forms. Tornadoes mostly occur in the Midwest and Southeast due to what is described as the perfect conditions for one to occur. These hotspots are the best places for one to occur due to the warm and cold air meeting in the right place. Let's take a look at this graph showing Tornado Valley.
From looking at this graph, we can see that tornadoes in the high plains and the southeast occur when dry, cold-moving air south from Canada meets the warm, moist air traveling up from the Gulf of Mexico, which creates this region known as Tornado Valley. And so when a thunderstorm occurs in this area, the warm, humid air rises, causing an updraft, and the cool air falls with rain or hail. These conditions will cause the air to rotate in the middle of the cloud, which updraft then catches this air, creating a funnel cloud, as shown by this graph. And then heavy rain and hail create downdrafts, dragging down the funnel cloud and therefore creating a tornado.
We know that Tornado Valley is shifting, which is why tornadoes can be found in states east of the Tornado Valley region. Traditionally, the region included states northern of Texas through Oklahoma, Kansas, and Nebraska to South Dakota, and this also included neighboring states to the east and west of these. And this shift of Tornado Valley is due to climate change, which has increased moisture in eastern environments, which provides the humid air needed for the tornado to form. In Connecticut, there have already been a few tornadoes that have taken place within recent years. They are weaker than common tornadoes and take place less frequently than the tornadoes found in Tornado Valley. And for a tornado to form in UConn, there would need to be an increase of moisture on campus to create a wind shear with strong winds that we already have present. For example, a thunderstorm could create these conditions. The cold air moving south from Canada we previously mentioned is also known as the Coriolis winds, which are high altitude winds that travel from Earth's north and south poles. The U.S. experienced Coriolis winds from the North Pole that blow in the direction of west to east. When both humid air and Coriolis winds blow in the same place, their directions contrast with each other and create a wind shear. The wind shear can then create a tornado. Let's take a look at the wind graph showing the Coriolis winds in Connecticut.
So if we look at this wind graph, we can see the air patterns traveling up from the Gulf of Mexico if you follow along this orange arrow. And you see that is the humid air that is traveling from the Gulf of Mexico into the region that is Tornado Valley. But if we zoom in on Connecticut and put the high altitude winds on, turn that on so we can see them, we see what is strong winds on this day. These are the Coriolis winds blowing from the west to the east in Connecticut. But if we zoom out back to the larger graph of the United States wind patterns, we can see that the region where the humid winds from the Gulf of Mexico are traveling up the U.S. is not interacting with Connecticut in the Coriolis winds that are happening there.
Let's go see what UConn's looking like. Come on.
Alright, right now it is 4:24 p.m. on the UConn campus, and conditions right now are 33 degrees Fahrenheit with gusts of 6 miles per hour. So although it is not windy today, the wind conditions at UConn can get pretty windy, around 30 miles per hour gusts of wind. And paired with some humid air, you might get a tornado warning, but you need the humid air for a tornado to form. So now Delaney and Kenzie are going to go show you some buildings around campus that pose a risk to the students here.
Alright, so we're back on UConn campus, and if we're looking around just this one square right here, we can see many problems in UConn's infrastructure if a tornado were to arise. So let's look at one example right now. Alright, so as you can see here, this entire building is mostly made of glass, which it would be an extreme problem if a tornado were to happen at UConn due to the flying glass and the interior being exposed to the elements, and also structural damage if the building were to be missing any walls.
There's also a lot of classrooms and offices, as we can clearly see from this building, so that would pose even more of a risk to the residents of UConn if a tornado were to occur here. Also, we saw in UConn's 2025 design guidelines that they're planning to implement windows that cannot be opened from the inside, which would obviously help in the event of a tornado. However, they should also be implementing these into their older buildings, as they will pose more of a risk.
Right, and over here we can see that different types of roofing are also a problem during a tornado. One example of roofing is this flat roof that you can see here on this building. This would pose as a risk during a tornado due to the different things that can be on the roof, like HVAC systems, solar panels, things like that. If they're not properly attached to this roof, then they can fall off and become hazards during a tornado.
Ways that we could avoid this is these systems could be placed on the ground. We could be having different roofing designs and adding shutters to them, also properly bolting them into the roof if not any of this is possible.
Alright, now as you can see, we're in front of Gamble Pavilion, home of UConn's basketball teams. And if you look at the roof, the roof is a dome shape, which is dangerous during a tornado due to roof uplift or roof collapse. This would be very dangerous for people in the surrounding area or even inside the stadium. To prevent this problem, roofs could not be made with a dome, or the dome could be extra fastened to the building. And if we continue this way, we can see an older brick building here at UConn, and if a tornado were to happen, the bricks would fall off the building and become hazards to everyone around.
Additionally, bricks are also probably one of the worst materials that a building could be made of in a tornado situation. FEMA usually recommends that buildings have metal conductors that go from the roofing to the base of the building. They also recommend that the foundation be made of cement, and in the event of a tornado, those would be the best materials to withstand one.
Alright, and if we turn around, I don't know, Mackenzie, if you can see those power lines right there.
Oh, I don't use glasses.
Yeah, maybe you need to put some glasses on. But over here we can see power lines with trees that run the road next to the power lines. This would be very dangerous during a tornado due to fires, electrocution, things like that. So what can UConn do differently?
I would say that they could use underground power lines. They could also try and plant trees away from the power lines.
Alright everybody, that's the end of today's video. We're the Gust Posters. I'm Delaney.
I'm Kenzie.
And I'm Avery. Make sure to like and comment down below.
Subscribe to our channel and let us know what school you want us to go to next.
Bye.